Hello everyone and welcome back to another video 2 of the challenge series in Dogma Summer Camp Design CAD. So if you haven't watched video 1 already, you really don't have to know that one for this videos or to be able to learn what's going on in this video. However, I still highly encourage you guys to watch that first video about chamfers and fillets. It's pretty interesting stuff. So today we're really going to be talking about one extrusion, and that extrusion is Loft. So already the name sounds kind of funny, but it can do amazing things. Now, along with Loft, we're going to cover some things called planes. Okay, so let's start with lofts. So what does a loft do? So a loft, like the description here says, is to create, add to, subtract from, or intersect parts by putting a smooth surface between ordered profiles. Now that is not English at all. So what that basically does, what loft basically does, is if I have let's say a triangle, and I have another triangle up here, if I created two sketches on two different planes that are maybe parallel to each other but don't have to be, I can create, I can pull both shapes together. So I can basically pull a polygon to another polygon if they're the same number of sides. Or I can pull any shape to a point. Now, what do I mean by that? So let me show you guys what I just mean. So let me quickly just create a sketch here on the top plane. Press N to get to the plane. And let me just do a inscribe polygon at the center here. Let's go with, I don't know, 5 sides, sure. And come here and exit the sketch. You can see here that I created that. And then we can create another sketch in the front plane. And then all I'm going to do here is just select the point thing, and boom, that is all I'm going to do. So here, now I'm going to select the loft tool, and it's going to kind of tell me what to do. So profiles, this is my first profile, and my end profile. Boom. So what you can see here is that I have used the loft tool to pull a polygon up to a point. So yeah, and that's also a demonstration of that. This is very different from extrudes. So when you're doing an extrusion, you have like a polygon, and then you press extrude, you press one face, and then you do, oh, how much do you want to extrude this by? 1 inches, 2 inches, whatever. But in this one, you can use two different sketches on two different planes to create something like this. So that is not even as interesting as it gets. So basically, I just showed you how to pull a surface or a polygon to a point. Now I'm going to show you how to pull a polygon to another polygon of different sizes. Okay guys, so here I simply just created a front plane sketch that just consists of a line. Pretty simple stuff, just go into sketch, then go into front plane, and then just do a line. You don't need to dimension it. There's really no point in dimensioning it even if you want to. Make the line pretty far from the midplane. There's really no dimension to do that, just make it pretty far. Okay, now using that line, we're going to create something called a line angled plane. So using the plane tool here, we can create different types of planes that are a lot better than their elementary planes. So Onshape by itself gives us 3 original planes, the front, right, and top planes for us to sketch off of and extrude off of and create different things. However, we can create our own planes that are a lot fancier and a lot better than the ones they give us. So let me just demonstrate that for you guys. Click on the plane tool. The first kind of plane you can create is an offset plane. Not very fancy, just select an already existing plane, and it can offset it, or basically create a plane that is 1 inch away from the original plane. So this plane 1 is 1 inch away from the front plane, or the other direction, also 1 inch away. So very not interesting. But the one we're going to create today is a line angled plane. So I'm going to deselect front plane and select a line like with the one we just selected here. Oh shoot. A line, not the point. So right now, still not very interesting, but when we change this angle to, let's say, 45 degrees, you can definitely see a change. Let me just pan around so you don't get that optical illusion. So that gives you a angle plane. Now, what that does is that you can, so what the, how you can create this is you select a line and the plane forms around that line and the plane can rotate off of that angle and create different angled planes. Now it's glitching a little bit here because I'm changing it really fast. Okay, let me just change it back to 60 degrees, which will give you that slightly slanted angled plane. So now let's build off of that plane. So now, similar to the other three planes, instead of sketching on those elementary planes, we can sketch on our fancy plane that we just made. So sketch, click our plane 1, and go up here, press N, and create another polygon, also of 5 sides, called a pentagon. Okay, and then click finish. Now you can kind of see what I'm going to do here. So let me go to trimetric view. So now press the loft tool again. So earlier I just demonstrated to you guys how to pull a point or how to pull a shape to a point. Now I'm going to show you how to basically pull a shape to a shape of a different plane also. So polygon to polygon. Now, wow, you already see the difference. So here, originally we just had a pyramid that had 5 sides at the bottom, but here we have a, a slanted pentagonal prism. So a lot fancier, and we don't even stop there. So now we can select something called match connections. So currently, what Loft does, CAD is lazy. That's what the Onshape software is. It's lazy. It doesn't want to twist or do multiple bends and something like that. But however, we can make it do some work and click the match connections tool. So using the match connections tool, we can do the connections and connect each point to another point in the ending profile. So what that means is that I can basically, instead of this point going all the way up through this line through this point, I can make this point go up to this one. So easily done if I just select this point and this point, and that twists the entire shape into a twisted and slanted pentagonal prism. Wow, already very complicated here, and we don't even stop there. Now I'm going to show you how to do something called a path. So that's even more complicated. We can create something that's out of our minds. Okay guys, so now you can see here that we've created our match connections loft using vertex to vertex and twisting it to creating that twisted shape. So now I'm going to show you how to create a path loft. So to create a path loft, obviously we need a path. So a path is any kind of line, can be curved or straight. So that's going to be created using a sketch on the right plane. So in the right plane here, we're going to use something called the project geometry tool, as you can see here. So the project geometry tool, like the icon kind of shows, basically copies, or it projects or converts edges or faces of a part onto the active sketch plane. So what that means is that if I use this tool and I click on any of these edges that are currently not on my sketch plane, I can copy it into the sketch plane. So if I take this shape, for example, I can copy this line onto the sketch plane without actually having to draw it. So let me press N again. And the ones we're going to have to project right now are the midpoint for this and the origin right here. So projecting those, we create 2 points. Using those 2 points, then we can connect a line through them to create our path. But obviously, straight things are very uninteresting, so we're gonna have to delete that and make some kind of arc. Because the reason we want this path to exist is we want it to be bended vertically also, and not just our horizontal bending by the match connection tool. So we want to use something called a 3-point arc. So 3-point arc, basically, you first select 2 points to indicate your start and ending point of the arc, and then you're gonna make the radius of the arc. So our start point is there and our end point is here, and then you can drag this around like this to make how bendy you want your arc to be. So for our purpose, we really do not want this to be bendy because since we already twisted it a lot using the match connection tool, we really don't want to twist it too much using the path tool because it's physically impossible for me to have it at this angle. So we're just gonna have it twisted or bended just a tiny bit like that. Okay, so now we have our arc, and now it's time to make our path. Actually, before that, it's really important to do something else. So our current sketch, which is our path sketch, it's below the loft. So some error might occur when you try to edit it, it will not appear. So you're gonna want to drag this sketch above the loft just like that to make sure that your loft 1 is below your sketch 4. So now edit the loft 1 by double clicking on it, and now click the path check mark, and it's gonna ask you to do any edges, curves, or sketches. And we're just gonna click a little bit on our curve here, and you can see that it's already gonna do a vertical bend. So that is a very, very twisting structure there. Wow. So yeah, this is probably gonna be the second to last thing that I'm gonna cover in this video, and the last thing is gonna be one of the most complicated things you've seen in CAD. So yeah, let me show that to you right now. Okay, so here again we have our lofted shape, our lofted pentagon created with path and match connection vertex to vertex. So now we're gonna create another loft that uses something called, that we didn't demonstrate here, starting profile condition, tangent to profile, or normal to profile. So first, we're gonna have to, oh yeah, and this loft is not gonna be like the polygon to polygon, it's gonna be another point to polygon. So to create that, we kind of want our point to be centered on this polygon and upwards. So to create that centering, we want to create another line angle. So the line for our line angle plane is going to be referenced on this same line, and we want that to be perpendicular to our plane 1. And remember, our plane 1 was created with 60 degrees angle, so we want this plane to be perpendicular to our 60 degrees angle, so we want to add 90 to that to make it 150 degrees angle. So create that, and here we created our plane, and that is perpendicular, I think. Yes, it is. So now we want our point to be on this sketch here. Press N to make that surface, and we want it to be kind of far away because we want it to be able to actually use the tangent and normal to profile. And again, it's similar to how, while we didn't make that curve so large for our path, we don't want it to break. That's the one thing that we don't want. So let's make it about right here. That seems far enough. Okay, so that's all you need for this sketch. And now let's loft it. Loft, profiles, starting profile is gonna be here, and the ending profile is gonna be our point. So far, we should be doing stuff that we already learned earlier. So, and again, straight edges, straight faces, uninteresting. So let's do some start profile conditions. So starting profile condition is basically, right now you see that from our pentagon to the point, the starting position is basically straight to straight, and that is none to none. So condition, we can set that to normal to profile, which means that it gets a perpendicular line at the beginning, and then it becomes straight again. So if we do normal to profile, all of these lines starting will become perpendicular to each surface at each point. So that creates this little, it kind of like blows up the loft a little bit. But the one I'm going to use, it's a little more interesting, I think. It's called tangent to profile. That shrinks it down a little, on the contrary. So yeah, that shrinks down a little as it is tangent to profile. So what tangent means is that it basically it starts out, instead of perpendicular, it starts out very flat, and then it increases in how steep it wants to be. So it starts out very flat and goes up, but the normal to profile starts perpendicular and goes up. So yeah, that is pretty much it. And for the ending profile condition, we can't really have many because the ending profile will be relative to the point, which doesn't have this plane on it. So that's why for our starting condition, the normal to profile works because it can be perpendicular to something. But for the ending profile condition, it's perpendicular to what? To a point that doesn't make any sense at all. So that's why we can have a tangent to profile and a normal to profile to this plane. And now let's check that, and we have our little sorting hat thing. And if this isn't already crazy enough, if you watched the challenge video series number 1, let's just throw in some chamfers and fillets. Let's just fill at the bottom here to make this look a little circular instead of the always sharp edges. Looks a little small to me, so I'm gonna make this actually 0.5 inches in. Much better. And let's throw in some chamfers on the sides. Just all around here, on this side and this side. Just gonna leave it at 0.2 inches. Actually, let me introduce it. Excuse me, what am I saying? Let me increase it to 0.25 inches. And yeah, that is our amazing and fancy shape. Let me just hide all these sketches for a better view. Hide plane. And then you can press P to hide the original planes and hide the origin also. And then we can use something called shaded without edges. And there it is, our loft masterpiece. And it is very complicated. So yeah, I definitely hope you took at least something out of that video. And if you have any questions regarding lofts and how it's applied in real life, please feel free to ask us. We love your questions. And yeah, take care.